Hi, this is Jim with an AP exam review. Today, we'll be starting off with circular motion. Alright, for circular motion, there's two types of problems that you'll see. Calculation and conceptual. For calculation, all problems, you're going to start as if they're any other force problems, nothing different. So you draw your free body diagram, and F net equals ma. The only difference with these problems is when you get to F net equals ma, your acceleration will be centripetal acceleration. So it'll be v squared over r. For conceptual, you'll have to know that centripetal acceleration always points towards the center, and that when objects are moving in a circular motion, they're constantly accelerating, even though they might have a constant speed because of changing direction. In these problems, you're going to look for any problem that involves circular motion, like a car driving over a hill, or a skater going in a circle on an ice rink, an object attached to a string that's thrown and gone in a circular motion, anything circular. You also see comparisons in gravitational strength, which you'll use your gravitational formula, which is G equals G constant mass over r squared. And remember, on free body diagrams, do not label centripetal force. It is only a name for the force. So if an object is attached to the string, centripetal force would be tension, so you would label tension of the string. Example question you might see, which our little red dot could be our sun and the blue dot is Earth. So we're orbiting around the sun. Label the acceleration of this diagram. So blue will point towards the centripetal acceleration, will point towards a red dot, and velocity would be the tangential to the actual sun itself. So it's always going to be pointing away, like you see in this picture. Alright, so our second topic is going to be rotational energy. For rotational energy, there's a lot more basically you need to know. Like for calculations, you're gonna do exactly what you did in the last one. You're gonna draw your free body diagram, but this time make sure you label each force where it is applied to the objects, and make sure you get the object specific shape. Once you label the forces, you're going to determine if it's clockwise or counterclockwise. To help with that, if you take your right hand and you cup your fingers to the way of the acceleration, whichever way your thumb is pointing will be which way the force will go. And to determine net torque, you're going to subtract counterclockwise torques out of the clockwise torques. Easy as that. Alright, so there are a couple things you should also remember. There's multiple ways to solve moment of inertia, which is basically mass, but in circular motion. So you'll have a summation formula, which is a summation of m r squared. And so that's going to be when you have multiple masses attached to the same object. And then for specific objects, so if they give you a square, you're going to use each object, they'll give you a specific formula to use to find that moment of inertia. And for another thing that you should probably remember is angular kinematics, which is not really part of this, but you should know. That can help you out during these problems, is that they can always be converted to linear kinematics by multiplying by the radius, and Newton's second law. Alright, what to look for. In these problems, you're going to look for when a force is applied to anywhere but the center of mass. And they ask for what's going to happen. Anytime when an object is rotating, they ask for anything with torque, moment of inertia, or something is on the fulcrum. If something's falling, how to change direction. The distance from the axis of rotation affects the problem, how it will affect that object. An object is moving without slipping, and a specific location of forces acting on an object are given. Alright, example question. A ball is attached to a string, is whirled around in a horizontal circle, having a radius of r. If the radius of the circle is changed to 4r, and the same centripetal force is applied by the string, the new speed of the ball which of the following? You can pause, work this out. If you got D, you're correct. Alright, so that is the end of my slides. Thank you.